recall what we are discussing in last class. I think we done a few numericals based on the basic definition of set, how to frame the roster form, tabular form, and how to form the rule method, or what is another form? Roster form and
Set builder.
set builder form. So that is called rule form. We done some based on that we done some basic numericals, and now I think we started the different types of sets after discussing the cardinal number.
Yes, sir.
Yes. Anyone can give the definition of the cardinal number? What the cardinal number says?
So the number of
Elements in a set.
Number of distinct elements.
Oh, sorry, distinct elements. Yes, sir.
Why I am mentioning distinct elements? What is the difference between distinct and non-distinct? Suppose if any set is having repetitions, the elements, the pictures or the images or the persons are repeated, distinct elements. Why I mentioned means, if any repetition is there, that repetition you should not consider. That will say the cardinal number. Now, different types of sets. Most of the types of sets, by seeing its name itself, we can able to explain types of sets. Each set I will give one or two examples. Guys, anyone having any doubt, please let me know. Here itself I will discuss about that one. One is finite set. Finite set. It is very simple. If the cardinal number is defined, then it is called finite set, or a set with finite number of elements. A set with finite number of elements. So by seeing the sets, you can able to say whether it is finite set or not. It is called finite set. So examples, anyone can frame your own examples. Set A, 1, 2, 3, 4. Set B, number of students in a class, in your class. Set C, odd numbers from 2 to 100. Will you agree with me? All these are finite sets?
Yes, sir.
Second one. Infinite set. Anyone can define by seeing its name?
So like the set does
Number of
not
elements is
have an
infinite.
Super. Might be your statements are different. The meaning of all your statements are same. A set with proper infinite number of elements, or the cardinal number of a set is infinity. The cardinal number of a set is not defined. All this comes under infinite set. A set which is not finite. I can say like this also, correct? Is called infinite set. The set which never ending of the elements is also called infinite sets. Examples?
Set
Which-
of natural numbers.
sir, set of natural numbers.
X says that X is a natural number. Infinite set. Any other examples? X says that X is a living thing in the universe. Any other examples?
The set of years.
This is a even odd number. I mean, sorry, even natural number.
Set of all rational numbers.
Sir, set of integers.
Set of integers, multiples of 3, multiples of 6, multiples of 10, everything will come under infinite set. Are you clear? Shall I go for next one quickly?
Yes, sir.
The next one is singleton test set. The next one is singleton set. Singleton set or unit set. What you can understand from this word, singleton or unit?
A single element.
Singleton set or unit set. A set which contains one and only element. A set which contains a set which have only one element. Then that set is called singleton set or unit set. Examples? Examples.
1.
Sir, 1.
X says that 2x minus 1 is equal to 3. Where x is having only one solution, no? That is nothing but the answer is how much? This is 4 only, no? Nothing but, sorry, not 4. 2. B. Any other examples, guys?
Which is neither prime nor composite.
Positive root of x square equals 4.
Next, many. You can give x says that x is a current president of India. At a time, two presidents can't be exist for any country, correct? And C, x says that x is an odd number and an odd integer between 6 and 7, 6 and 8. So the answer is 7. In tabular form, this is a set. Any other examples, guys? Any other examples? You can create your own. The next one is null set. Null set or empty set. Anyone can define?
A set which does not have any element.
A set which does not have any elements. The cardinal number of the set is how much here?
0.
Which does not have any elements. That means n of a. If a is a set, if n of a is 0, that is called empty set. If n of a is equal to 1, that is unit set. If n of a is equal to finite, that is finite set. If n of a is equal to infinity, that is called infinite set. So this is singleton set, finite set, infinite set, and this is called null set. So everything, if you are able to connect it to cardinal number, it will be easy to remember these types of sets. Anyone can give the example of the empty set or null set? Generally, empty set will be represented like this.
So natural number between 5 and 6.
This is a symbol for empty set, guys. It looks like pi. This is empty set symbol. We will represent empty set with this. Yeah, examples.
Natural number between 5 and 6.
Natural number between 5 and 6. X says that x is a natural number between 5 and 6. Any other examples, guys?
Even prime number other than 2.
Yeah, even prime number x says that x is an even prime other than 2.
Sir, x is an odd number divisible by 2.
Correct. X is an odd number divisible by 2. Super. Any other examples? X says that x is an odd number can divisible by 2. Next one. X such that X is a natural number which is less than 1. X such that X belongs to natural number where X less than 1. There is no natural number exists which is less than 1, correct?
Yes, sir.
Generally, these all the sets will represent with null set is always the symbol of null set is like this. We won't represent with any number. Anywhere set 5 means this is called null set. Cardinal numbers of this set is null set. Shall I go for the next one?
Yes.
Yeah. Next one is joint sets or overlapping sets. Joint sets or overlapping sets. The meaning of joint sets or overlapping sets. This definition can explain with the help of more than 2 sets. Then only I can explain this definition. If two sets are said to be joint set or overlapping sets. Joint sets or overlapping sets. If they have at least one element in common. The meaning of this is at least one element of the two sets should be common. What are the element available? Suppose if I am saying A is a set 1, 2, 3, 4, 5 and B is a set 1, 6, 7, 8, 9. Then I can call A and B are joint sets or overlapping sets. Why? Because in set A, 1 is available, in set B, 1 is available. At least one element should be common. At least. It might be 2 elements or it might be 3 elements also should be common in both the sets. Understand, guys? What is the overlapping sets?
Yes, sir.
So can you give any example of overlapping sets in set builder form? Anyone?
A is equal to prime number and B is equal to an even number.
Correct. A is equals X such that X is a prime number. B is equals X such that X is an even number. So even though at least 2 is common in both, correct? Any other example for joint sets or this one? Any other examples? Guys, expecting some other examples? A and B. Can you give any other examples for joint sets or overlapping sets?
Sir, natural numbers less than 6.
X is a natural number, set of natural numbers. X such that X is a whole number. I can say these are the overlapping sets.
Yes, sir.
Except 0, all other elements are common in both the sets. That means minimum, what is the requirement to say these are the overlapping sets? One element is enough, but more than that also it is possible. So it's not only one element should be common, any number of elements, but at least one element should be common. Got it, guys? What is the meaning of overlapping sets or joint sets? Shall I go for the next one?
Yes, sir.
Disjoint sets, opposite to this. Disjoint sets. So same as two sets are said to be disjoint sets. if they have no element in common. Example, set A, E, I, O, U. Set B, 1, 2, 3, 4, 5. Is there any element common in both the sets? No. In this case, these two sets are called disjoint sets. Any other examples?
Set of odd numbers and set of even numbers.
Yes, list of odd numbers. And B is set of all even numbers. So set of odd numbers and set of even numbers also disjoint sets. Any other examples, guys?
Set of rational numbers, set of irrational numbers.
Super. P is a set of rational numbers x such that x is a rational number. And Q x such that x is an irrational number. Anyone, guys? Any others can give some other examples? A, set A, x such that x is a positive integer, set B, x such that x is a negative integer. I can say that is also disjoint sets. Guys, am I right what I'm showing? What I'm saying?
Yes, sir.
Another example in little bit real life. Set A, list of the students in DAV school, and set B, list of the students in Hindu school. One student can't study it simultaneously in both the schools, correct?
Yes, sir.
So that is also one kind of little bit practical way of explaining some sets, disjoint sets. Joint sets, disjoint sets should be little important. You have to keep it in mind, because in some questions they will start the question like this: given A, B are disjoint sets. That means you have to understand whatever the elements are repeating in A, there is no element is repeating in B. At least one element also there is no common. Why this term I am pressing and explaining? You will understand when I am dealing some questions. Next one is equivalent sets. There is a difference between equivalent sets and equal sets. I will show you. Equivalent sets. The meaning of equivalent set means irrespective of what kind of elements available in the sets, two sets said to be equivalent if they contains same number of elements. Same number of elements. Suppose if set A is equal to A, B, C, set B is 1, 2, 3. That means number of elements in A is equal to 3, number of elements in B is equal to 3. Then this set is called equivalent sets. Understand what I'm saying, guys? If the cardinal number of the any sets is equal, if the two sets having the same cardinal number, then those sets are called equivalent sets. Now see the definition of the equal sets on the same page. It will be easy to understand what is the difference between both. In case of equal sets, when we can call two sets are equal sets, not only number the elements also should be same in the other set. Two sets are said to be equal if both the sets have same identical elements. Sets have same elements. Then only we can call as equivalent. Equal sets. Equivalent we will use, equal we won't use much. So set A, if I am saying 1, 2, 3, 4, 5. Set B, they are giving in some other form X Z. X belongs to N and
X is lesser than 6.
X less than 6. In this case, if I am converting into tabular form, I will get the same kind of elements with the same number of elements. So this I can call as equal sets. In this case, A comma B are called equal sets. Guys, is it clear? In equivalent sets, the difference is all equal sets are equivalent, but all equivalent sets are not equal sets. Am I right? Understood what I'm saying? Guys?
Yes,
Shall
sir.
I,
Yes, sir.
can I? All equivalent are not equal sets. It is not necessary. All equal sets are equivalent.
Sure, the opposite way, sir.
No. Yes. All equal sets are equivalent only, no?
Yes, sir. Yes, sir. Sorry, sir. Yes, sir.
All equal sets are equivalent. But all equivalent are not equal. Equivalent means if the cardinal number is same, that is enough. But for equal sets, cardinal number should be same, and as well as the same type of elements should be available, same identical. It's like a copy of the same thing. Guys, done? Shall we proceed some numericals quickly on this topic? Guys, shall we proceed some numericals?
Yes, sir.
Yeah.
Sir.
See, all are like word problems, like 1 mark numericals only they might ask from this. They won't ask many tough or something. But MCQs and entrance point of view, this based on this one, they will ask the questions. Just give me a minute. I'm opening a small worksheet related to this. Give me a minute. Within 5 minutes, we'll complete this those numericals, and we'll continue. Just a minute. Hope you can able to see the screen. Correct?
Yes, sir. So,
What is the first one? Who is going to give the first one? Answer. So no need to solve. There is no calculation based here. All are like by knowing the definition, you can able to answer this one. Who is going to give the answer for the first one? Anyone? Harshida, can you try? Hamsini or Harshida? Akshay?
so first one answer is 5, sir.
So this one is okay. I will write here. He's on. What is the question? Can you explain the question and tell me why 5 is the answer?
So the number of elements in the set is 5.
Cardinal number. So the answer is n of a is 5. What is the second one?
Sir, 4.
N of b is 4. What are the elements, man? 3, 4, 5, 6. Correct?
Yes, sir.
What is the answer for A3? N of A3 is how much? Two P minus 3 is less than 8. And P is only whole numbers.
So 5, sir.
5, sir.
Sorry, 6, sir. 6.
2P minus 3 is less than 8. 2P is less than 7. Correct?
Yes, sir.
Less than 11 by 2.
11 by 2, that is 6. Answer.
Why 6, man? This is P is
So number of elements is 6.
5.5. 0, 1, 2, 3, 4, 5. Correct. 6. 6 elements. So the answer is 6 here. Understood, guys? How the answer is 6 in A3? Anyone having any confusion? Guys, please respond. It looks simple, but some questions makes literally we have to think a little. I can't say it's a straight questions. Anyone wants explanation for 1, 3? Guys, shall I move to the next one?
Yes, sir.
What is the N of A4? Yeah, somebody is asking something. So A4 equation is what? My B belongs to Z. What is the meaning of Z, guys?
Integers.
Integers.
Integers. And the given statement is -7 less than 3b minus 1 less than or equal to 2. I am adding the whole equation with +1. So -6 less than 3b less than or equal to 3. I am dividing the whole equation with 3. -2 less than b less than or equal to 1. So then b is what? B is equal to -1,
-1, 0, 1.
1. That's it. So what is the N of A4?
3.
3.
This is how we have to connect to solve this one. If you are unable to clear, put on pen on paper. Then it will be. What is the N of P? Second question. N of P. Permanent. P E.
R M A N E won't come, sir. E and N won't come. Then P.
E is repeated. T is not came. Correct? Only E is repeated. E is here and E is here, and N is also repeated. P R M A P E R M A N T. P E R M A N T. So 1, 2, 3, 4, 5, 6, 7. So N of P is 7. Guys, are you clear? You have to take distinct elements. Understood? Why N of P is 7?
Yes, sir.
Yeah, next question. Shall I move to the next question? Who is going to explain this question? Hamsini, can you try? Which are finite and non-finite? Infinite. What is A?
First one is finite, sir.
X such that
Sir,
X
it's infinite, sir.
it is
Sir,
infinite.
first one is infinite, sir, because integers.
Integer means it might, X less than 10 means it will be 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, and so on, -100, and so on, -1000 up to -infinity. So it is infinite.
Okay, sir.
Look into the relation properly. The relations makes us little bit clear. We have to understand the relation. Yeah. So what about B?
Finite, sir.
5x minus 3 is equal to 20, correct?
Sir,
5x
lesser than equal to, sir.
23. So less than or equal to 23. So x is less than or equal to 23 by 5. And x is a whole number. 23
0,
by 5
1, 2,
means
3, 4.
less than or equal to 4.15. So 4.2, correct? So 0, 1, 2, 3, 4. So it's a finite.
Sir, 4.6, sir.
Yeah, 4.6. So the set is 0, 1, 2, 3, 4. So 5 elements.
Yes, sir.
So what about P? Finite or infinite?
Infinite.
Why infinite? Because it is greater than 5. When x is greater than 5 and x belongs to n, y is equal to 3x minus 2 means you can substitute any value in x, you will get n number of y values, correct? Infinite number of y values you will get 5. If you substitute 6, you will get 1 y value. If you substitute 7, you will get 1 y value. Because 3x minus 2, there is no limit for x values. Each and every x value, you will get 1 y value. So this is infinite. What about m?
Infinite.
Guys,
Finite, sir.
n belongs to whole numbers and n is between 6 and 15. So n is starting from 7, 8, 9, 10, 11, 12, 13, 14 and 15. So it is limited. For each value you will get 1 R value. When it is 7, 3 by 7. When it is 8, 3 by 8. When it is 9, 3 by 9. When it is 10, 3 by 10. So it is finite. Everyone can agree with these answers? Anyone having any confusion or doubt or any deviated answers? Shall I go for the fourth question? Guys, please.
Yes, sir.
Yes, sir.
Yeah. Who is going to do fourth question? Which of the following sets are singleton sets? The set of points of intersection of two non-parallel straight lines on the same plane.
Sir, it is not a singleton set, sir.
First one is not a singleton set. I am
Yes,
saying
sir.
singleton set.
Sir, but I'm saying it's not a singleton set, sir. Because two lines can also be in the opposite direction and coinciding.
Yeah, because he didn't mention. He said only non-parallel. Got it? What I'm saying? But there is a little ambiguity here. In some cases, coincident lines also we can consider as parallel lines, man.
Yeah, actually, yes, sir. It's singleton only because lines has both the direction. It goes on, right? So it's not a ray.
The lines having same direction, never meeting, called parallel. Parallel doesn't require direction. Even the lines are opposite direction, never meeting, called parallel. And if
Yes,
the
sir.
lines
Yes, sir.
are coinciding, also parallel. It's a one particular case of parallel, correct?
Yes, sir. Yes, sir.
So other than this, we can draw only like this. two straight line never meet two times again. It will meet only one time. So I can call it is a singleton set. Everyone agree with guys? What is the remove the confusion?
Yes, sir.
Yes, sir.
Yeah. What about the second one? This is singleton set.
Yes, sir.
Yes, sir.
sir.
It's singleton.
Singleton. Third one.
It is not a singleton, sir.
Why it is not a singleton?
Sir, because they told y is equal to whole number, sir. So many values will come.
Whole numbers means how many values will come?
Sir, they gave less than 3,
Less
sir.
than
So
3. 2y is less than 2, y is less than 1, that is 0 comma 1. So more than one element, then it is not a singleton set.
yes, sir.
Fifth question. Find which of the following sets are empty. What is the meaning of empty set? No
Null set
element,
No
has
elements, sir.
no elements. Yeah. Who is going to give the answer for this? Set of points of
So
intersection
the
of
first question is ambiguous, sir.
Sorry?
The first question is ambiguous, sir, because two coinciding lines can also be called as parallel lines.
Yes, the set of point of intersections. So if I am considering a coincident lines is non-parallel, then this is ambiguity. If I am considering, if I am not considering two coincident lines, this question will become an ambiguity. So the set of point of intersection of two parallel lines. So definitely it is an ambiguity. But if I am considering, if I am not considering the concept of coincident lines, if we mention two different parallel lines, then you can get the answer. So as of now, we can consider ambiguity is there, but if we mention two different parallel lines, then it will be what it is.
It's
It's a null set.
yes, sir, null set, sir.
What about the second one answer? There is no natural numbers between 5 and 6, correct?
Sir, I have a doubt.
Yes, sir.
Sorry?
I have a doubt, sir.
Yes.
Sir, so null set is also a singleton set.
Sorry?
Is null set also a singleton set?
No, null set is not a singleton set. N of A is 1, that is called singleton set. If N of
Sir,
A is 0, then it is called null set. How you can say both are same?
no, sir. Then in the fourth question, first subdivision, can you tell why you wrote yes once again?
Which one? First subdivision.
Yes, sir. In the fourth question.
That's all I am telling now. The question is an ambiguity. If I am not considering the case of overlapping lines, understand? If I am not considering the case of overlapping lines, then only I can able to give the proper answer. Understand what I am saying?
No, sir.
See, there are three set of lines in a plane you can draw. One is intersecting, another one is parallel, another one is coincident. Correct?
Yes, sir.
So here I am not considering this case. Then only I can able to answer first question of fourth one and first question of fifth one. Otherwise, I am not going to consider these are the questions. I can say it is not even set also because it is not properly defined. Instead of two parallel lines, you can say two different parallel lines. That means coincident lines is same lines. Coincident lines represent same equations. So then I can say that's the reason I mentioned that statement I am explaining. If same question, if it is repeating, I can say it is not a proper question. You have to assume something and we explain except coincident lines, it is null set, except coincident lines, it is a singleton set. Understand what I am saying?
Yes, sir.
If I am considering coincident lines is a parallel lines, then my answers can't be explained here.
Yes, sir. Got
The
it.
question itself is a wrong, I can say, or concept of coincident lines you should not bring here. Got it?
Yes, sir.
Sir,
Yes.
The second subdivision of fifth question is a singleton set only, sir.
How it is single? Yes, sorry
Sir,
guys.
because it is less than or equal to 6 they gave now, sir.
Yes,
So
yes,
6 will
it
be
is a
there.
singleton set. It is a singleton set. So not null set it is. It's not. Correct. What about 3? 3 I am saying null set. Will you agree?
Sir, no, sir. Because
sir.
x is a natural number, sir. So
X
many
square
values can be
plus
there.
4 is equal to 0. X square is equal to minus 4. That is x is equal to root of minus 4, which is no natural numbers are possible. Correct or not?
Yes, sir.
Yes, sir.
So no solution. It doesn't have any solution, so it's a null set. Even numbers between 6 to 10. Not a null set.
8 is there, sir. Yes, sir.
Prime numbers between 7 and 11. Prime numbers between 7 and 11.
Sir, no, sir. Null, sir.
Null set on
Sir,
analysis?
I have a doubt, sir.
Yes.
Yes.
Sir, a decimal number can also be considered as a prime number, right?
How we can consider decimal is a prime number, man? What is the definition of prime number?
Sir, it shouldn't be divisible. It's only divisible by 1 in itself.
It's only divisible by?
Number 1 and itself.
Yeah. So decimal number, you are saying decimal number can't be divisible by anything?
When
you can consider decimal number is completely different numbers now. Prime numbers can be defined only for natural numbers and whole numbers. And am I right? Are you going to define prime numbers for rational and irrational?
No, sir. No, sir.
Correct or not? When you are talking a decimal, decimal is nothing but a rational number only now. Suppose if I am taking 0.7,
Yes, sir.
what is the meaning of 0.7? It's a 7 by 10. It's a combination of two numbers. One is prime, another one is non-prime. How we can explain 7 by 10 as a single number? It's a kind of a number in between two numbers. For convenience, we have created a new number system called rational numbers. How you can
Yes,
apply
sir.
prime number concept here? If I am trying to apply the prime number concept, what I will do here, I will show you a proof. 7 by 10 I can written as 70 by 100. This 70 by 100 can be divisible by with 10. Then how I can say it is a prime? You take any decimal. If I am taking 0.007, this can be written as 7 by 1000. I can't say it is divisible by any number. I can write this is 70 by 10,000 and I can say this number is divisible by 10.
Yes, sir.
In that case, how we can define? There is no proper definition for the prime rational number. We won't define prime concept to the rational numbers because it is completely irrelevant, because rational number having many forms like fractions. All like fractions represents a single rational number, correct?
Yes, sir.
Clear, guys? What I'm saying? Why you can't
Yes,
define
sir.
a
Yes, sir.
prime concept for a rational number?
Yes,
Correct or
sir.
not? Anything confusion in my discussion or explanation? Anyone having
No,
any
sir.
other doubts? Guys, this is how I'm expecting, because this will use a lot of knowledge when you are discussing together in a group. Yes, any others? Shall I move to the next question?
Yes, sir.
Yeah. Little things are missing. I will explain what is missed. If the question is not clear, I will read it. So all the sets A is equal to 4, 5, 6 and B is equal to x square minus 5x minus 6 are disjoint. When you can call two sets are disjoint sets?
When they don't have any common element.
Yeah. So the elements of A is 4, 5, 6. What are the elements of B?
Sir, 2 and 3.
2, 3. Is there any common element?
No, sir.
No common elements. So set A
Sir,
and B.
there is common element, sir.
What?
Sir, 6, sir.
How 6, man? How 6 is common element?
Sir, B is actually 6 and -1, sir.
X square minus 5x can be written as correct. No, minus 2x minus 3x. No. Minus 6x plus x minus 6. So x minus 6 into x plus 1. So the
Yes,
answer
sir.
is,
It's
Yes, sir, it's -1,6, sir.
then solution is wrong. It is 6, minus 1,6 is the solution. So there is a common element. The common element is available, so it is not disjoint. It's a overlapping of joint sets, not disjoint.
Why can't we write -3x and -2x?
If I'm writing -3 and -2, x minus 3 into x minus 2 is x square minus 3x minus 2x plus 6. That is not the given data. No? The given data is x square minus 5x minus 6, not plus 6.
Yes, sir.
You are violating the given data. They gave one equation, you are considering another equation to solve the set B. What about second one?
Not a disjoint set.
B, C, D,
Sir,
E.
actually disjoint set, sir.
How disjoint, man?
Sir, because that is in small letter, this is in capital letter, sir.
This is lowercase, this is in uppercase.
Yes, sir.
So definitely it is disjoint sets. What about the seventh one? Who is going to explain seventh one? Guys, please come forward and explain. I'm expecting answer from everyone. You are grown up. I can't call each and everyone name by name. State whether the following pair set are equivalent or not. Equivalent means number of elements in A must be equal to number of elements in B. Find the cardinal number of A, cardinal number of B. What is N of A and N of B in the first question? What is N of A?
Sir, I guess N of A is infinite.
Infinity. What is N of B?
7.
How N of A is infinity, man?
Sir, N of A is 6, sir.
N of A is not infinity. 11 is greater than 2x minus 1. 2x minus 1 is less than 11. 2x is less than 12. X is less than 6. And x belongs to natural number. So 1
So N of A is 6, sir.
equal to 1, 2, 3, 4, 5, 6. So N of A is 6. What about N of B?
7, sir.
N of B is 3, 4, 5, 6, 7, 8, 9. So N of B is 7. So it is
They are not equivalent.
not equivalent. N of A is not equal to N of B, so not equivalent. What about the second question, guys? Set of integers and set of natural numbers.
Not
Not
equivalent.
equal.
Not equal, sir.
I can say it is undefined question. Guys, can you tell why?
Yes, sir.
because
Sir,
the number
because,
of
number of
integers are
integers
not
is also
measured.
infinity.
Why means the number of integers also not defined because there is no beginning and there is no ending. But when it comes to number of natural numbers, there is no ending. Both we can consider as infinity undefined. Actually, this question, they asked the number of integers from minus 100 to 100, number of natural numbers from 0 to 100. Then I can say something, but it's kind of confusing question. Set of whole numbers and set of multiples of 3.
Sir, again,
No, sir.
not defined, sir.
Not no, multiples of 3 and whole numbers. It is also not defined. We can't say, but one point of view we can say, if you are taking a finite number of elements, definitely whole numbers is more than multiples of 3 because a few numbers are not multiples of 3. Definitely, it is not a equivalent. But when it comes to number system point of view, set of whole numbers also infinity, set of multiples of 3 also infinity. So both are undefined kind of statements. These are which can't form as a proper sets. It is not well defined set, I can say, if I am considering two sets together. What it, guys? What I'm trying to say? What kind of questions we may face sometimes?
Yes, sir.
So multiple answers they will consider as the right answers here. You don't worry, even if you keep it is not a equivalent sets also, they might consider your answer is correct. You don't think if I am not defining also, they have to consider this as a right answer. What about the fourth question?
So not equivalent.
5, 6, 7, 8. X is a whole number less than or equal to 4. So there are n of p is 4, n of m is how much?
5, sir.
So n of p is 4, n of m is 5. So it is not equivalent. So there are two more questions. After this, we are going to discuss some other definitions. What is a subset? What is a complementary sets? And proper subset, improper subset, universal set, superset,
Power set.
and set operations. After set operations, practical problems on set operations using Venn diagrams. That is the end of this. So might be this week we are going to complete the sets concepts. Let's see whether we can able to do it or not. I am going a little bit in deeper. Once I completed the discussion, we will go through the textbook scan copy and let's see whether we covered everything or not. If I am missing 99%, I am not going to miss anything, because suppose I'm a human errors can be possible. If I'm missing anything, please remind me. I will explain. Okay, guys.
Okay, sir.
So we'll meet in next class.
Yes, sir. Thank you, sir.
Yeah. Bye, everyone. We'll meet in next class. Bye.
Thank you, sir.
Sir, bye, sir.
Thank you.